Okay, in Goal 10.1, we are simplifying square roots. I have listed here the first 20 perfect squares. You probably maybe have the first 10 committed to memory, maybe the first 12, the first line up there. Probably not too many of the second line, okay? They're committed to my memory simply because I use them a lot. In teaching geometry over the years, I use a lot of squares. So they're committed to my memory. But, you know, like I said, probably the first 10, maybe first 12, you have committed to memory. I'm not going to ask you to memorize them. You'll be able to use your chart and use your calculator. But it's good to know. I will stay probably within the realm of these 20 numbers. Okay? When you're looking for the square root of something, you're going to be using the radical symbol, that little symbol that's over the number. It's not necessarily called a square root symbol because you don't know this probably. But when you look at that square root of 16, there is a little understood 2 there. They don't write it there because you've never talked about any other kind of root before. But when you get to your other math classes, they can put little 3s there, or 4s, or 5s, or any number, okay? And that's different roots. When there's not a number there, we know it as a square root, okay? So I just want to mention that, that's worth mentioning. And when you're looking for a square root of something, the reason that's an understood little 2, because a square root means 2 of something. Find something that times itself gives you that number or variable expression. So 2 things, groups of 2 things multiplied to give you that. I don't think you'll have any problem with perfect squares because we can use our calculator and we can use our charts, okay? But let's talk about them first. Let's talk about them first and then we'll go to our non-perfect squares. The square root of 16 is 4. 4 times 4 is 16. The negative square root of 64 is negative 8. That's the only time your answer is going to be negative, is if that negative is out in the front. The square root of 100 is 10. The square root of 289. And if you didn't know that one, you could go to your calculator. You could go down the right side of your chart and see if 289 is in the chart, and it is. Go to the left and you'll see it's 17. Probably not one you know off the top of your head. The negative square root of 1 is negative 1. The square root of 361, again, not one you probably have committed to memory, so calculator or chart, and we get 19. All of those could have been punched into a calculator. Variable terms, nope, not going to work on a calculator. Okay? When you're working with variable term, the concept is still the same. You're still looking for what 2 things multiplied together give me this. So when you say the square root of x squared, you're asking what times what is x squared, and that's x. When you're taking the square root of x to the 12th, you're asking what times what gives you x to the 12th, and that's x to the 6th. Because what you got to remember from way back, last semester, is that when you multiply, you add powers. So if I'm looking for the square root of a variable term, all I have to do is divide the power by 2. So the square root of x to the 28th is x to the 14th. Here's a little trick question. The square root of x to the 36th is x to the 18th, not x to the 6th. Okay, so for a power, we're going to divide it by 2. The square root of x plus 3 to the 8th is x plus 3 to the 4th. 8 divided by 2. So I can take the square root of a quantity the same way I would take the square root of a plain x. Power divided by 2. And I'm going to star this one too. This looks like it's going to be negative, but it's not. it is a positive 5x. 2 divided by 2 is 1. You're basically ignoring this. And this is why. I'll show you in another color. If I took this question and I actually calculated negative 5x squared. I'm not sure why I put in parentheses there because I don't need that. Meaning I would take negative 5x times negative 5x. It would become positive 25x squared, whose square root would then be 5x. The square root of 25 is 5, and the square root of x squared is x. So a little bit of star question on that one, commonly missed. That is a positive answer. So I'll repeat what I said earlier. The only time your answer is going to be negative is when the negative's in the front. Okay? All right. Take a second. 30 seconds, I don't know. Take that in for a minute. 30 seconds, 20 seconds, I don't care. And see if you have some questions to ask. Well, okay. We're going to go to non-perfect squares because honestly, that's what happens most of the time. Perfect squares are not most of what happens. I don't foresee a lot of problems with perfect squares. Non-perfect squares, a little harder. Okay? All right. So, for non-perfect squares, for all the rest that I'm going to do here, you have to break your number into two factors. Now, factors are just the things you multiply together. That's what a factor is. With one of them being a perfect square. And this is where I'm going to teach you to use your chart. What I know is that some of you are going to be really good at square root. You're not. You're probably going to hardly look at that chart ever. And some of you are going to use it every time you do a question. Okay? So we're all going to be at different places with this, but I'm going to teach you how you can use the chart to make it simpler. Okay? Simplest form means that there is no perfect square factor under the square root sign. Okay? So, for example, 18, square root 18. 18 is not a perfect square. Whether you look at your chart, you know that from your brain, or you use your calculator, 18 is not a perfect square. So our job is to make it two things multiplied together that give me 18. But I want to make sure that one of those things is a square. So this is where I'm not going to choose 6 times 3. 6 is not a square. 3 is not a square. Okay? So some of these you're going to get very quickly off the top of your head. Some of them you're probably going to want to use your chart to help you get that pair. So I'm going to show you how to use the chart right now in this question. So if I look at the right side of the paper, 18 is not listed, which means it's not a square. So I go to the number, the biggest number smaller than 18, which is my 16. So I would ask myself, does 16 divide into 18? No. Does 9 divide into 18? Yes. So I'm going to take 18 and make it 9 times 2. 9 is a square. Perfect square. One of these numbers that you break it into needs to be a number from our chart, a perfect square number. So then my square root of 9, that's going to come out. The square root of 9 is 3. The square root of 2, we don't know, so it stays under the radical. That's what your final answer looks like. 3 square root 2. 48. So we go to our chart. Now you might need to use a calculator to do this part, or you can just use your brain, whatever you can do or need to do. So 48, the largest perfect square smaller than 48 is 36. So I would go 48 divided by 36. Nope. 48 divided by 25. I'm working my way up. No. 48 divided by 16. Yes, sir. 16 times 3. So I'm going to take the square root of 16 is 4. The square root of 3, I do not know. And that part stays under the radical. $500. I'm looking down the right side. 500 is not in my list. So I'm going to go up the chart all the way from the bottom. And again, some of you are just going to know what it is. You're not going to have to use your chart to find that pair of numbers, and that's great. Okay? So 400, no. 361, no. 324, no. 289, no. 256, no. 225, no. Da 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 da. Keep going up. And finally, I get to 100 times 5. The square root of 100, that's my perfect square, that's 10. The square root of 5, I don't know, so that part stays. So 10 square root 5. Two square root 75. 75, not a perfect square. So I'm going to use my chart, and I'm going to divide. 64 does not divide. 49 does not divide. 36 does not divide. 25 does. So 25 times 3. Now this one's a little bit different than the other ones we've done. So I've got a 2 that's out there. I've got the square root of 25 is 5 that I'm going to bring out. My 3 is going to stay. And then I'm going to multiply those and get 10 square root 3. So if there's a number on the outside at the start of the question, like this one, and you bring a number out, like the square root of 25 is 5, those numbers are going to get multiplied together, not added, multiplied. So 10 square root 3. Similar on this next question, except I have a negative, only difference. 288, look at my chart, 288, not a perfect square, so I'm going to work my way up. 288 divided by 256, nope. 288 divided by 225, nope. 288 divided by 196, no. 288 divided by 169, no. 288 divided by 144, yes. And again, if you don't need to do that division, you know what the pair of numbers is. Don't go through all of that. Okay? So I have my negative 3 that's out there. I have my perfect square. The square root of 144 is 12. And I've got my 2 left. And then I multiply negative 3 times 12 and get negative 36 square root 2. This next question is commonly missed because people go 9 times 8. But that's not going to be the correct answer because there's a bigger square. So this is where the use of your chart is really nice. 72 divided by 64. No. 72 divided by 49. No. 72 divided by 36. Yes. Most people don't think 36 times 2. When they see 72. They think 9 times 8, which is not going to be the right answer. So then I have the square root of 36 is 6. The square root of 2, I don't know, that stays under the radical.